a previous video, we discussed how managed aquifer recharge could help increase the groundwater in the summer by putting more water onto the fields in the winter. But how does Dr. Laura Foglia,
Audra can talk better than me about the geochemistry,
and her team test if this actually works?
Through the power of geochemistry.
We're using a couple of different environmental tracers to try to understand the timing and location of interconnection between the river and then the groundwater aquifer.
Environmental tracers are markers that occur naturally in water and can be tracked as they move through a watershed. Specifically, they track hydrogen isotopes and the element radon.
Each one of those two types of environmental tracers give us slightly different but complementary information. For stable isotopes of water, those are going to give us more information about water source dynamics and water source contribution to the river at different times in the year.
Water from different sources will have different isotope fingerprints. That means hydrogen isotopes in a lake in the mountain will have different fingerprints than a ditch in the valley. Since the team's goal is seeing if putting water on the fields in the winter could help the aquifer stay higher in the summer, they collect water from different places around the valley and check how these environmental tracers, or fingerprints, move. Every 2 weeks, they sample water from creeks and ditches upstream of the recharge site.
Oh my God, this is high.
Yeah.
So when we're ready to take our isotope sample, what we do is we go down to the water, we will use the syringe, so we'll suck water in and push it out. We do that 3 times. We put this little filter on, and then we'll push the water through the filter, then fill the vial with the filtered water, and then that's our sample.
Then they sample water from the ground using wells. This way, they can get a rough idea of when the surface water they put on the fields for recharge reaches the groundwater, and then when the groundwater reaches the river.
So for the radon gas, it's a really nice way to locally track influx of groundwater into the river.
When the water flows through the geology, it will accumulate radon, and we can use that as a natural tracer.
Water that comes from rain or snowmelt doesn't pass through rocks or earth, so it has no radon. So if there's radon in a creek or river, that means it's being fed in part by groundwater. Depending on the time of year, the Scott River will have a different mixture of snowmelt, rain, or groundwater. By tracking radon over the last 2 years, they've been able to see that the percentage of groundwater in the Scott River is higher in the summer and early fall.
So when we're thinking about how to actually connect back what we're seeing in the river to the recharge activities that are taking place on the farmland, that's a trickier situation. That's why we're using these geochemical tools, these environmental tracers, in conjunction with other approaches. Those are things like the physical measurements made in the wells throughout the study area. Looking at the fluctuations in groundwater elevation and temperature, they can give us some insights as to how the water is moving from the surface applied on the fields down into the saturated aquifer zone.
All this data also goes into the hydrologic model, which is a physics-based computer simulation that can test out different water scenarios. If you want to know more about the hydrologic model, I made a video about that too.
and then with the model we can really try to nail down, okay, when is the water that we apply in a certain spot making it to the river, and when and where.
And last year we were able to apply water continuously from around January 15th to the end of March. I think the 17-foot increase in groundwater that we saw at one of the wells last year was really exciting. It's a really large amount, and you don't see that with just precipitation data. And so I think the landowners can track this information too, so they can see how much their groundwater levels are going up.
So the groundwater recharge is really just one component of all the things that we are doing in the valley. So that's something to keep in mind, because we really need to be very careful at saying that recharge is not just one solution. We need to look into different type of solutions.
Just remember, folks, if you're not a part of the solution, you're a part of the precipitate. No, I swear I won't make chemistry puns in every video, just periodically.